Good day, good afternoon, ladies and gentlemen. A very warm welcome to our today's Digital Asset Management event. We are broadcasting live from MR headquarters in Regensburg, Germany. I'm standing in our co-creation center where we have set up a transformer equipped with many great products from our portfolio. On behalf of MR and our subsidiaries in the region, we would like to welcome you. Deep in our hearts, we would like to welcome you here at MR in Regensburg. Unfortunately, this is not possible due to the circumstances. Nevertheless, we have put together a very interesting program for you. Get comfortable and enjoy our today's program. During the webinar, you have the possibility to ask questions in the Microsoft Teams chat. Our experts are there to support you. If you do not wish to discuss your topic in the Microsoft Teams chat, please leave a comment. Our expert get in touch with you. My name is Christian Scheider. I'm the regional sales engineer responsible for the entire Asia Pacific and China region. Today, I'm supported by our expert, Mr. Bastian Fischer. He is the head of business development of our business unit, Automation. And of course, our experts in the region. Last but not least, the team behind the camera is also there. Now let us have a brief look at our today's agenda. I will shortly introduce the Renhausen Group to you. We'll talk a little bit about different maintenance strategies, the operating principle of the OLTC, maintenance intervals of the OLTC, why maintenance is so important for your on-load tap changer, and of course I will present some retrofit solutions to you. This is just a small part of our wide portfolio. However, most of them, what we present today, you can easily combine with the OLTC maintenance or can be performed within one day. MR has been founded in 1868 and our trademark was established in 1901. We have around about 3,600 employees worldwide. Quite an amazing number is that 50% of the worldwide electricity consumption passes through our products, and that more than 80% of all our products ever delivered are still in service today. Quite amazing for me and makes me proud every day to see these high numbers. On this overview photo, you see that the tap changer is installed in the transformer main tank and connected to the regulating winding. The tap changer itself is divided in the main components, which you can see here on this overview. We have the OLTC oil compartment. Inside, we have the diverter switch insert, and below, we have the tap selector. On the left, you see the movable contact system. This is the inside view of in the DSI. And below the transitions resistors, which you can also find on the diverter switch insert. When a switching signal is given, the motor drive unit initiates the complete switching process. This takes approximately 5 seconds. The diverter switch insert itself switches in the last third, and this takes approximately 40 to 50 or 200 milliseconds, depending on the OLTC type. Now let us have a deeper look into the different OLTC technologies. On the left side, you see the conventional, already known technology, and on the right, our VacuTap technology. The main difference is here in which medium the switching process takes place. Left, we're switching in mineral insulating oil, and on the right side, we're switching inside the vacuum bottle. So you can see that we have no longer any carbon particles as we are switching in our vacuum bottle. It's more or less a complete sealed system. So we're using the insulating oil just for insulating purposes, for cooling and lubrication. On the left, we are also using the oil for arc quenching, and therefore we have carbon particles, carbon bodies inside our insulating oil. Here I brought some, for sure, known maintenance strategies, the preventive maintenance and the corrective maintenance. The preventive maintenance can be divided in time-based, condition-based, predictive, risk-based failure finding. The corrective maintenance is, of course, not recommended, but sometimes, as you see in emergency cases, cannot be avoided. But with regular maintenance, you and we can do the best to avoid such critical scenarios. Time-based is known from the conventional technology, tap changers, and condition-based predictive maintenance can also be done with a monitoring system. Now, we have a deeper look into the OLTC maintenance intervals. On the left, again, we have the conventional technology, and on the right, the VacuTap technology. The conventional technology has two different maintenance categories. So we have either the time in service interval or the number of tap change operations, whichever is reached first. For conventional technologies which are used in network application, the time in service interval is the most common one. The number of tap change operations you will just reach when you have a transformer which is operating under harsh conditions with very high number of tap change operations, which can also, where you also have the need to do a tap selector maintenance arc furnace application, for example. So depending on the application, the type, and so on, we can say that time in service interval for conventional technology is necessary between 2 and 7 years, or between 20 and 150,000 tap change operation. When we now look to the VacuTap technology, we have just a number of tap change operations. And this is necessary between 300 and 600,000 tap change operations, which means we have no time-based interval. And for the most network applications, that means that this tap changer type is maintenance-free. You can do some annually checks, for example, to be sure that your system is in safe operation. You can check the heater of the motor drive unit, the seals, the housing, the drive shaft arrangement, everything what is possible to reach when the transformer is in service. Check the signals, for example, or if the transformer is switched off, you can also climb up, check the sealing of the head cover, the protective relay, the pipe connections, and so on. This you can do. And a very important thing is that you check your dehydrating breathers of your transformer and, of course, your tap changer. The oil, depending on the application, should be checked every 2 years when your tap changer is in delta application, or every 7 years when you have a star point application. This you can find, all this information you can find in the operating instruction for your OLTC or for your motor drive unit. There is a special chapter, Maintenance and Inspections, where you find all this detailed information. Or when you're using a TapMotion ED, for example, there is a sticker inside the door when the next maintenance interval should be performed. Should you already use a monitoring system from MR, for example, the TapMotion ISM, our new product, the Ethos, or a TapGuard, for example, the maintenance interval will be displayed in the electronic device, so you will get the information directly from the system when the next maintenance should be performed. Here you can see some challenges which you may be aware of or you already faced. And of course, the aim is that we avoid an unplanned outage of the transformer. And MR developed some solutions, these are just a few examples, to reduce the challenges on your end. And here these are the examples. Shouldn't you have any personnel available, MR can come on site with 2 specialists. And this is an example photo from a Germany truck, which we have here in Regensburg. This truck is equipped with a crane, an internal workshop. We bring all the oil pump, all necessary tools and materials, and we can travel to site. This service we can also offer in different other countries. Should you be interested, just contact your well-known contact person or leave a comment in the chat. Our experts get in touch with you. Now we came to the topic, why is maintenance so important? I brought here an example from an old Tap M tap changer, And the first topic is the mechanical stress. We have an energy accumulator where we have springs inside, we have braided leads, we have flexible leads, of course we have some screw connections, and we have a mechanical wear also on the complete system and as well on the tap selector contacts. As I said in the beginning, normally for network application, maintenance is just needed to external parts, so means motor drive unit, protective relay, diverter switch insert. However, should you reach high number of tap change operations, a tap selector maintenance is also necessary when we measure the contacts or need to replace them depending on the condition. Here, two photos from arcing during an OLTC switching operation. The movable contact system switches from left to right. The below photo shows an arcing from a main contact, and the photo on the top shows a photo of one resistor contact. So either when the contact is opening or closing, depending on the voltage, on the load factor, on the application, it can be more or less. This is depending on the application. However, this is a normal, totally normal occurrence for conventional OLTC technologies. What is then happening, or how it looks like when we reach the maintenance interval? The diverter switch insert looks dark, black. So we have, according to this switching process, we have the switching arcs and all carbonization. And this all carbonization immigrates on the insulating surfaces, which you can see on the top. And below you see an example contact from the inside of the contact system. So we have the movable contacts and of course the fixed contacts. Here 3 example photos from left to right. This is the Alt-Tap M, Alt-Tap R and Alt-Tap V. Don't get shocked from that black color. This is a total normal occurrence in conventional technology. However, if the parts are not regularly checked and cleaned in combination with high water, this can form or can reduce the insulating distance, and in the end of the day can form a grippage path where we then have a flashover inside the OLTC or on the insulating cylinder, for example, which then leads to a failure or outage of your transformer tap changer. Then, of course, we have some environment influences on the tap changer cover, on the protective relay, drive shaft arrangement, the Bavergay unit, the motor drive unit housing. All this, what is outside on the transformer, you may for sure know it, is exposed to rain, thunderstorms, sun. Here in Germany also we have hail, or if it's installed closely on the sea, we have also the effect from the salt water, which affects the equipment as well. So it should be cleaned, regularly checked, maintained, lubricated, that we ensure everything is in good condition. One very important point is that MR is not just developing our new products, we are developing also the products which we have in our current product portfolio. So for example, on the top, we have the contact leads. In the past, they had a maintenance interval of 150,000 switching operations. MR developed them forward, and now we can give this benefit to you. So the contact leads must now be changed between 300 and 400,000 switching operations, which is very good. And below, flexible leads. This is a contact shell of an Alt-Tap M. Left is the former design, and on the right side you see the flexible lead, after the maintenance. So we are also upgrading them. Another example for an upgrade is the energy accumulator. We completely designed the energy accumulator new. So the bottom plate is new, and the interesting thing is that we also designed the energy accumulator itself new. So when MR started to have the Alt-Tap V in the product portfolio, this was 1979, we delivered every Alt-Tap M with tension springs. This is the photo on the left. And since a few years, we have the energy accumulator with pressure spring design. I brought also one energy accumulator with me, which you can see on the front. So the blade is completely new, and the main part is the energy accumulator with the pressure spring design. The camera tries to zoom in that you can also see that energy accumulator which I brought with me. I just turn it a little bit. This is the new pressure spring energy accumulator. However, the complete gear is completely new designed. And the benefit is that there is this gear is completely maintenance free. Once it is installed, it must be replaced at 800,000 switching operations, which is the same interval as for the selector switch insert of the AllTap V. These are just two examples, one from the AllTap M and one from the AllTap V. Of course, there are some more upgrades, but important to mention that we are not just pulling out the diverter switch insert, cleaning them, putting them back. We carefully measure everything, check, and also upgrade these components for you. The next very and sometimes forgotten topic is to check the oil quality. As I mentioned a few minutes ago, for Delta application, you should check the oil quality. You should check the oil quality every 2 years, and for Star application, every 7 years. Furthermore, you should check the condition of your dehydrating breathers or upgrade them to maintenance-free breezers. We have also one M-trap installed on our transformer here, and we will give you a short inside overview photo or overview of this M-trap. This is the new one, our Mesco M-trap 2.5. Has 3 LEDs installed, a data logger, and on the right side a push button where you can check the system. In the past, this push button was an option. Now it is already installed that you can check the system. Pretty good. So once you have installed, for example, this Mesco M-trap, you never ever have to worry about to check them, to check the condition, to replace the silica gel. It's also good for the environment. So no more waste from that silica gel. This M-trap has a self-drying algorithm which dries out the silica gel and is completely maintenance-free. Should you want to know more about our M-trap, you can also go to our Reinhausen YouTube channel, where the function of this breather and for some more products is shortly explained in some short clips. What can happen, for example, if no maintenance is carried out or the maintenance is performed too late? Here I brought 3 example photos of a tap changer where the maintenance was not performed regularly. So it can lead that just a small part is damaged or the complete tap changer, or that you lose your complete transformers. We have 280 qualified and trained specialists. So they get a theoretical training and of course a practical training, which they have to do again every 2 years for each motor drive unit and for each tap changer. So we will not send out a specialist which is not trained on an AllTap M, for example. And if he has to do a maintenance on an AllTap V, he has to do also the theoretical and practical training for this tap changer. We are doing this to ensure the higher quality standard, where we are proud of, and to have everywhere around the world the same knowledge and the same standards. Yearly, we perform approximately 6,000 service jobs in different countries at different end users. So to them, customers who already trust us, thank you very much for this high number. And of course, we have also specialists who can perform maintenance on non-MR tap changes. Feel free to contact us if you want to have more information on the non-MR tap changer maintenance or on the MR Siemens AEG Trafo Union maintenance. MR took over this business from Siemens AEG Trafo Union in 1989. So we have all documents, drawings from these tap changers available. qualified specialists around the world available, OEM spare parts available. So should you need any information for this type changes, or do you have some in your fleet, just let us know. We are happy to support you. So what do we need if you want to get a budgetary offer, for example? We need just the serial number of your old TC. If it's an MR one, it would be good to get the location and, of course, the scope of work to calculate the offer. The serial number can be found either on the head cover of the old TC, this is the top photo, or on the motor drive unit sticker. This is an example from the TapMotion ED, but also our MA7, MA9 has a nameplate on the door where you can find the serial number and a little bit more information. Below you see the full service truck. So if you require that we come with material plus our specialists, with a crane, with the oil pump and all necessary equipment, we come with this truck in Germany. In other regions, maybe the truck looks a little bit different, or completely, or we come just with a van, for example, and the crane will be ordered separately. This depends on the region, on the availability, but more or less we can offer this service worldwide. If you have non-MR tap changers in your fleet, a photo of the nameplate would be good, that we can see the type of tap changer and the serial number. For MR cases, we have everything in our system as we are the manufacturer. For non-MRs, a photo of the nameplate would be very helpful for our experts.
And that you get a little bit an information how such a maintenance is performed. We prepared a video for you for an arc furnace application in Turkey, and this we want to show you now. I hope you enjoyed the video. So this was an arc furnace application. So you saw that we measured the contacts. I also brought an example here with me that you can see the contacts live in our co-creation center, a new one and an already used one. A single pole OLTC maintenance can be performed within 1 day. So, now you can see the contacts. On the top, this is contact on the end of his lifetime, and below there is a new installed one, which you could also see in that video. Perfect. As I said, a single pole maintenance can be performed within 1 day. In this example, this was a 3-pole application, so this is also possible within 1 day with 3 specialists, of course. We carefully check everything, measure, check the sum and single contact, note everything in our digital service report. This data will be transferred back to our system. This allows us to offer next time the maintenance without, for example, a data acquisition at site, or that we have to ask you for further information. We need then just the serial number and then the current number of tap change operations that we can calculate the necessary maintenance material. On this slide, you could already see some benefits at a glance. So we have 24/7 availability. We have approximately 60 years of service history. We give 2-year warranty on the performed service and on the installed material. We can perform MR tap changer maintenance, Siemens AG Trafo Union, as we took over in 1989. Furthermore, non-MR tap selector maintenance. Last but not least, we can offer tailor-made solutions, which you will see now. I will come to the retrofit and upgrade solutions. I think this is a very interesting one, to upgrade a conventional OLTC into a vacuum maintenance-free tap changer. Are you ready to start into the future? In this animation, you see an all-tap M, all compartment, and now the all-tap M diverter switch insert is removed, and the VacuTap VM diverter switch insert is installed, and the cover is closed. What you see in this animation is more or less happening in real life. Of course, there is all in the tap changer, there's a drive shaft arrangement connected, but it is more or less a plug-and-play solution. There is no modification work necessary on or in the oil compartment. No other modification is necessary on the tap changer. We deliver this tap changer, this diverter switch insert for this tap changer, ready for operation, means dried and tested, HV tested, and ready for installation. But what can be a reason to do this? I collected some examples for you. For example, your installed transformer fleet grows, or you have a mixed portfolio in your fleet, so that you have a mixed technology. So you have all taps, conventional tap changers, and that you have some VacuTaps already installed. And if you want to have a unique technology in your fleet, this is the solution. You never ever have to worry about in network application to perform a maintenance. Another reason can be that your transformer cannot be switched off, or just during night times, or you have no spare transformer available, whatever. This can be some reasons. Maybe you know some of them, or you face other one. A very interesting one is also with this diverter switch insert, you can reduce, for example, the fire risk of your tap changer with alternative insulating fluids. This is possible. This solution can be also offered for all tap T's and R's. There are some small modifications necessary inside the oil compartment, but in the end of the day, it is also more or less a plug-and-play solution. Here, no modification necessary inside the oil compartment on the T's and R's. There is, to be honest, but no problem to do that. For the VM, we delivered already more than 1,000 retrofit diverter switch inserts, also not the complete production what we delivered, just the retrofit TSIs. These are more than 1,000, and we also delivered quite a few for the OLTAP T's and R's. Let us compare in detail the OLTAP M with the VacuTap VM. On the left, this is the conventional technology, the OLTAP M, and on the right, the VacuTap VM. You see that the lifetime of this DSI is already 400,000 operations higher, so the lifetime of the M is 800,000. Compared to the VM, it is 1.2 million. The important thing is that the maintenance must just be performed at 300,000 tap change operations. This is a very high number, and for sure you reach that just when you operate your transformer in harsh conditions. I think, or you for sure know that for the most network application, this tap changer is then completely maintenance free. The VM offers also the possibility to perform a dissolved gas analysis DGA, and of course some more benefits which you can see in this overview. How, or when it comes then to a maintenance, how does it look when we compare both technologies? On the left, you maybe remember that photo from the beginning. We have the conventional technology. It looks dirty, already dark colored, and also the oil inside the oil compartment in that small animation looks more or less completely black. On the right side, we have the VacuTap VM, and the oil inside the oil compartment looks more or less brand new. And this white small image, that symbol is the vacuum bottle. So this is more or less a complete sealed system, which allows you that you have no carbon particles inside your tap changer oil. This upgrade is also possible for licensed tap changer based on OLTAP M or R, whatever. That this is possible, I brought also a short video with me where we install a TapMotion ED on a non-MR tap changer and perform a retrofit from conventional technology to VacuTap technology. Have fun with the video. Okay, I hope you enjoyed this short video. You hopefully saw that this retrofit upgrade is also possible with a non-MR tap changer. In this case, the request was also to upgrade the motor drive unit and to make the OLTC maintenance free for the end user. We know that this investment pays quickly off for you. As I mentioned, you have several benefits. A few I brought already and showed reasons, and here at a glance some more benefits which you get with this VM upgrade and also with an upgrade to an VR tap changer. So 300,000 tap change maintenance free, the contact lifetime compared to the conventional technology, which is between 200 and 400,000, is in this case 600,000. The lifetime is 1.2 million. You have an enhanced transformer availability to do these reasons, and we are doing vacuum tap technology more than 30 years now. Of course, this makes sense to combine it with our MSense portfolio or with that already shown Mesco MDREP maintenance-free briefer, that you fully enjoy a maintenance-free transformer equipped also with maintenance-free dehydrating briefers. In that video, you saw that the motor drive unit has been upgraded. Now I want to go more in detail. Here I brought some motor drive units with me. Of course, these are not all, but I think these are the most known one, common ones, or that one which are still in operations. From left to right, you see the MA7, MA7-8. They look more or less identical. Then we have the MA9, the small one, which you often see on all Tap Vs and on some all Tap Ms. The Tap Motion ED, the most common one. We have the Tap Motion ED since 1998, so where we start with the delivery approximately until today in our portfolio. And since 2018, we have our Ethos, which you can also see on the transformer, or you saw on the transformer behind me. This is our new intelligent motor drive unit, or you order this Ethos without drive function, that you have just a monitoring solution for your tap changer or transformer. This is all possible with our new Ethos. The former or older motor drive units can have some problems. And here I brought some reasons. For example, the older former ones, they are not touch-proofed because it was not state-of-the-art. They have no run-truth protection. Till the first MA7s, they were delivered with oil-filled gears which can start leaking. This is not just an MR topic. This happens also with non-MR motor drive units. Here I brought an example. When the door was closed, the motor drive unit looked more or less okay. Then I opened the door and I saw that there was an electrical damage inside, and the end user couldn't operate his transformer. He asked me if it's possible to replace it, and yes, we can offer this service also for a non-MR motor drive unit. Which data do we need to create you a budgetary offer? In case of MR, we just need the serial number, scope of work, the location to calculate the travel costs, and that's all what we need. If it's a non-MR, we have a checklist which we can provide to you, and you can fill in all the required information. What is always good to have in case of a non-MR is a photo of the nameplate, a wiring diagram, and an overview photo of the transformer, that we can see the drive shaft arrangement, because the lengths and the dimensions are often tricky if we have no idea how it looks in real time. Or what we can also offer, that we come on site, make a data collection together with you, that we take all photos, fill in the checklist together with you, discuss this project, and afterwards we are ready to go to prepare an offer. So more or less very simple with the checklist. In case of an MR, totally easy. We need just the serial number of the motor drive unit, and then we can prepare an offer for you. How it is looking when we have prepared the offer, you choose us and we can deliver a motor drive unit. I also brought a video with me where we remove an MA9 from a transformer here in Regensburg and install a TapMotion ED. This is our training transformer for our specialist in Hasselbach, and we prepared this video for you. I hope you enjoy it.
Hello everybody, welcome here now to our live event. Now we want to disassemble our motor drive unit. Therefore we have prepared our new motor drive unit and also the bevel gear, the drive shaft and everything what we need for that replacement. The first thing when we start with the replacement, we have to go with the motor drive to the adjustment position, because the new motor drive is also delivered in the adjustment position. After that we have to control that there is no power on the terminals in the motor drive. When we have checked that, then we can disconnect the power supply. After that, we start with the disassembling of the vertical and the horizontal drive shaft. When this is disassembled, then we remove the upper bevel gear, and after that, we will start with the removal of the motor drive unit.
We hope you have enjoyed our video and gained some interesting insights how we perform a motor drive unit replacement on site. Just to summarize it again, if you want to perform an upgrade, this is possible with MR tap changes, MR motor drive units, and non-MRs. For non-MR, we have a checklist which you can fill in. Here on this slide, you see a non-MR motor drive unit replacement, left non-MR, on the right our installed TapMotion ED. And together with the budgetary offer or with the technically clarified offer, depends if we have all necessary information, you get also an information sheet what you have to prepare for the OTC maintenance, or what you have to prepare for the replacement, for the retrofit from M to VM, for example, or for the motor drive unit replacement. Switch off the transformer, for example, cordon off work areas, check some signals that there is no connection to the transformer, and so on. All this you will get with our offer, and of course also with our order confirmation, that you can forward it to your technical team, and they can go through these documents and know what needs to be prepared. Should anything not be clear, you can contact directly the contact person or our technician which is going on site. They will inform you, of course. The next retrofit solution I brought with me is our oil filter unit. This is just necessary when you have a conventional technology tap changer and do not want to upgrade them to VacuTap. We recommend it to install it when your tap changer is performing more than 50,000 switching operations per year. A few tap changers are already equipped with an oil filter unit. When they're operating in harsh conditions and it's a tricky application, for example, then we deliver the tap changer set inclusive the oil filter unit. However, this is also possible to install it once the tap changer is in service, to extend the maintenance intervals from, for example, 100 to 150,000 tap change operations for the old tap M, for example. On the top and below, you see some installations what MR did with inclusive piping. We have a very cool system that we can install the oil filter unit without any welding, without any sparks on site. We crimp the pipes together and install them on the transformer. The last retrofit solution I brought with me is a complete modernization of your transformer, a midlife refurbishment. The pictures below show that we enter the manhole, can crimp leads, or there is one example where a non-MR tap changer onboard one was installed, where we designed a complete tank, installed the tap changer in the tank, pre-assembled the leads to connect them to the barrier board, replace bushings. Bushings, we can replace just the gaskets on the bushing, upgrade the motor drive units that they are smart grid ready, or just with new signaling that you get the BCD signal, whatever you require. This depends on your needs, and we design the offer that it fits to your individual needs. I hope you gained a little bit an insight about what is possible with asset management. Of course, these are just some small examples from our very wide portfolio. We also heard a lot about maintenance, condition-based maintenance, and predictive when we install a Ethos, for example. MR has developed a very fascinating solution where you can listen into your tap changer when it's in operation. Our expert, Bastian Fischer, will explain vibroacoustic monitoring, AMS and SWAM, in detail to you. Hi, Bastian. Just a few seconds. He has to check his microphone, and now he's coming. Should you have any questions in the meantime, still use the chat function. You can raise your questions there,
or leave a comment, feel free. Our experts are there to support you. And now Bastian is ready to come in. Hi, Bastian. Welcome.
Good afternoon, ladies and gentlemen. My name is Bastian Fischer, and I'd like to give you a few more details on how to leverage and collect the data on the OLTC for optimizing the maintenance as it was described by Christian Scheider. So the topic is, how can we monitor OLTC, and what are the challenges, and why specifically the OLTC? Well, as we look at the Seagray statistics, among the reasons for transformer deviations and failures, we see the OLTC comes with 31%. Although the maintenance is conducted in all, with all recommended measures, unforeseeable events can happen. The OLTC is the only mechanical part and the only moving part in the transformer, and for that reason, it is also subject to wear and tear. Well, there are solutions for that. First, we can listen and monitor very deeply into the OLTC. We can retrofit sensors for your entire fleet, whether new or old transformers, and whether OLTCs from MR or non-MR. For that, of course, it is important to collect as soon as possible the correct behavior, to understand what is correct operation, where are the deviations, and whether immediate action or later on some corrective actions are needed, as described by Christian. Well, we can record very easily the correct operation of that OLTC. For that, we can simply retrofit the OLTC with one little sensor. It is on top of the OLTC. Here, very small, it's just the size of my hand. It can be mounted on every OLTC, and it requires only a short intervention to retrofit such a microphone on the head of the OLTC. I leave it up here to give you an indication of the size. Well, that OLTC microphone, as I call it, or the stethoscope, like any doctor is using it to understand the heartbeat and to listen to the heart of the patient. It captures the vibroacoustic signal of the OLTC and gives you a constant information how well the OLTC is operating. Now it helps you constantly online detection of early recognition of anomalies. It helps you to avoid any outages and serious failures or incidents. And it covers the complete switching operation of the different components of the OLTC. I'm saying that because, yes, you might be aware of other OLTC monitoring technologies, such as motor current index or torque measurement. Well, those are some of the traditional OLTC measurements and monitoring features, but they have one common disadvantage. They only cover the area where there is some torque. And as Christian explained, the OLTC switching operation by itself does not require torque because it is powered by the spring, by the forces of the loaded spring. And also that operation can now be captured with the vibroacoustic monitor. Now, that vibroacoustic sensor is bolted onto the OLTC cover, just replacing one nut of the OLTC cover and screwing and replacing that nut by the VAM sensor. That VAM sensor records constantly the vibrations and the sound. It compensates for temperature and different viscosity of the oil, and feeds all that data into the MSense VAM monitoring unit on the lower right of the slide. Now, that MSense VAM monitoring unit is made of the exact same modules as described earlier from the intelligent or the digital transformer described by Christian. So there are, once you are familiar with the Ethos modules, they are exactly the same for the MSense VAM monitoring unit. Or vice versa, if you start with MSense VAM, you can also expand that installation with additional transformer monitoring capabilities. Well, just to give you an indication of the 3 steps as described earlier. During the OLTC operation, the VAM sensor is recording the sound and vibration pattern. Then, in a second step, is transferring that pattern to the MSense VAM analysis unit, which is built and installed on one of your cabinets at the transformer. Now, that analysis performs a comparison between the actual recording and the confidence band. Now, I'm using 2 terms here. One is the blue line, which is the actual recording, which is simplified from the high resolution signal frequency band, which is recorded or displayed here. And then the yellow line, which is the confidence band I was talking about. That confidence band, as you can see, depends on each OLTC and varies from OLTC step operation to step operation, whether you have a small step, a reverse step, or large step. So that confidence band is actually calculated and approximated via artificial intelligence, self-learning methods, which are built into the MSense VAM analysis unit. Well, what we see here is actually the actual recording is exceeding, is crossing, is breaching that confidence band, and therefore creating an event. Now, I can show you that immediately on the screen. For that, I will operate a few operations. Let me open the Ethos cabinet, which allows me to operate the OLTC. During that time, I will be quiet because you will hear also over the microphone the OLTC operation. So that is the opening of the cabinet. Let me operate the OLTC. I will be quiet. Okay, the diverter switch has operated. I will now move to the screen to show you what has happened. What we see here is the depiction of Ethos with the different elements for navigation, as well as the key components of your transformer, the bushing, the winding, the OLTC. Let me switch to the OLTC. We have the overview of all switching operations. We can look at the torque monitoring, one of the OLTC monitoring capabilities. We have the VAM analysis, and today I'd like to move directly to the VAM analysis and display the pattern of the recording we have just operated. The system is now aggregating all the high fidelity data into the blue schematic, which represents the actual operation, and it also indicates that none of those blue actual operation has crossed the confidence band. So that OLTC is operating within the margin of confidence, and therefore no irregularity is detected. Well, we have other examples which I've prepared on the slides, which gives you clear indication that an activity, a maintenance activity is required. Again, we have here a crossing of the actual recording exceeding the confidence band. Now, MR gives you not only indication that something has happened and an inside view is required, but also gives you additional support. And together with our experts in the regions, we can analyze that high fidelity signal band to get into the root cause assessment of that deviation. Well, what can we detect and how is that recommendation communicated back and analyzed? The result of that analysis is a detailed VAM analysis report, which gives you actionable insights. What has been tracked, against which data has it been compared, what does the statistic of similar OLTC reveal, and what are the next actions, the recommended actions for you to take. Now, that depends, the recommended actions depend on the detected irregularities. So let me move into what are the mechanical, electrical, or corrosion effects we are detecting. First, let me just give you an overview that with VAM, we truly listen inside the OLTC. And that is so much more, gives so much more information than only monitoring the motor current index or the torque. We can discover a slight weakening of the spring, which indicates that the timing slowly changes from the ideal behavior. Of course, we can also recognize sudden changes, for example, coming from a broken or a loose bolt. That can happen. This is material, this is subject to wear and tear, and some unforeseen mechanical breakages can happen. So therefore, as something loosens, as something weakens, that goes detected in VAM and can be maintained. So we have actual examples from projects where, based on the data of the M-Sense VAM, we could avoid any defect, any larger unforeseen outage, or even a larger repair job incurring a longer transformer repair or a longer outage. Now here in this picture, you see the normal signal pattern of a normal, well-maintained OLTC. On the bottom here, the frequency comes from the pumps, from the fan, as well as the transformer 50-60 hertz vibration noise. So that on the bottom here is the normal noise which is filtered out and is not relevant to the analysis. Then we have a few markers in the operation: the selector switch off, the selector switch on, and then the big mechanical noise you have also heard, the diverter switch operation. So that's the normal operation. Let's walk you through some deviations which we have recorded with M-Sense VAM and helped our customers adjust their maintenance pattern and also take improvements in their processes. Well, on top, a section of the normal operation, on the bottom, the actual project measurement. And what we see here, between those markers, there is much more noise than the normal noise coming from the fans, from the pumps, etc. So there is some anomaly going on in that area. Well, looking into the data and going on site, once the event, M-Sense VAM has triggered the event, we looked into the OLTC, looked into the data and said there must be some grinching and wear between mechanical parts. We didn't exactly know where, but that has revealed the further analysis. So in this case, there was a maintenance work done by the operator of the transformer with a subcontractor. Well, it was in an area with high rain season. Of course, they covered up their maintenance area with a tent, with plastic shielding and tent. Unfortunately, the rain was so heavy that pockets of water came from the tent into the open OLTC and it created a significantly increase of humidity inside, leading to a corrosion on the diverter plate. So when opening the OLTC, we discovered a thick layer of rust, which indicated that there was a significant raise of humidity. Well, the appropriate oil sanitation was performed, the cleaning was done, and the root cause was identified. This is a good example where early recognition of a deviation gives you a hint to perform maintenance before any major accident failure happened, before breakdown, voltage, and short circuit creates a bigger incident on the transformer. The second example is a similar noise, but this one was not as pronounced. You see that here on the picture. Here. Now that noise came from a selector, a torn part in the OLTC, which, because our OLTC is over-dimensioned, didn't create any severity, any incident on the actual OLTC, but of course that torn part created more noise and a replacement was required. The last example is a question of timing. So on the bottom now you have the correct operation. We see the diverter switch operation here in the correct pattern. Unfortunately, this OLTC has a few milliseconds delay. Now again, our OLTC has enough safety margins to cope with those variations. But as those variations wear out and out and out and get longer and longer, the mechanical part will reach a limit where it can create an incident. So with VAM, that timing delay was recognized, the gearing was adjusted and corrected prior to any impact. Now, you might think this is all theory. In the next few slides, I'd like to walk you through examples where we have actually retrofitted VAM, and not only in distribution transformers, we have retrofitted MSense VAM to the most critical HVDC stations of large transmission lines, connection lines. These are 3 examples from China where MSense VAM has been installed on 3 large hydropower plants, routing energy from west to east and north to south, and retrofitting MSense VAM in an existing transformer and a tap motion installation. Every station is very large, with over 28 transformers on each station, and therefore a sound, meticulous project was created. And during that retrofit, we also introduced and retrofitted a second measurement, the motor current index, the tap motion statistics, as well as the oil and OLTC temperature monitoring. A few additional signals and values which can be integrated into MSense VAM to make the OLTC monitoring more complete. For the OLTC monitoring, a few steps were done in advance. The site assessment to inspect every single transformer and substations. Once that site assessment was conducted, within a few days, this entire process took about 3 days. Within a few days, the brackets for the mounting of the cabinet was executed. The routing of the communication and data cables, signal cables, were executed. The mounting, as I indicated, on the OLTC for the temperature. Then actually the mounting of the VAM sensor. It's so small you barely see it. It's a replacement of 1 bolt and mounting, that's the top view, mounting of the VAM sensor, putting all the cables into shielding, mounting the MSense VAM and Ethos cabinet onto the bracket, and then in the last part connecting the Ethos MSense VAM control cabinet with the pre-existing tap motion terminals. At the end, commissioning of the MSense VAM monitor and releasing it back into operation. Well, the longest part was the assessment and the mechanical mounting of the brackets and the cabling. The rest here was done within 2 days, installation 1 day, commissioning 1 day, and releasing the MSense VAM for production. So we have, and together with Christian Scheiter, we developed, and each subsidiary, we developed a checklist for you to conduct the retrofit in a structured manner with all the learnings we have across the different projects. And that will shorten the pre-assessment, that gives our colleagues from asset management a clear indication what to do, when to do it, who to engage, in what sequence, and to build and work with you on a project plan and a task list and spare parts to retrofit MSense VAM in the shortest possible time. Now, in summary, the OLTC VAM monitor is an innovative sensor proven in small and large OLTCs, having over 400 measurements and deployments already done in online and offline versions. The MSense VAM can be installed on any of your OLTCs, whether MR OLTCs, whether non-MR OLTCs, new OLTCs or older OLTCs, because it has a self-learning algorithm automatically recognizing what's correct and where does the system recognize sudden or slow developing faults. For that, it gives you the best possibilities for recommendation. It gives you an early indication before things happen of any activity needed. With that, I'd like to conclude the presentation of MSense VAM and invite you back to the chat, and also ask my colleague Christian Scheiter back on stage for any questions you might have submitted into the chat room.
First of all, thank you, Bastian, for the interesting insight. A very great product, interesting product, and of course, a good possibility to monitor your tap changer when it's in operation. I already checked the chat shortly. We received already a request, so thank you very much for your trust that we already received a request, and 2 questions regarding asset management. To summarize it shortly, the retrofit possibility M2VM is more or less a plug-and-play solution. So there is no modification work necessary on the oil compartment, and there is no other modification necessary. There we have to open the drive shaft arrangement, to open the cover, remove the diverter switch insert, install the new one, of course clean everything, check for damages, refill it with new oil, close the head cover, connect everything together, perform test operations over the entire switching range of the individual OLTC type. Then it's completed. Then we complete the service report, hand them over, and transfer the data points which are important for us to our system. And as I mentioned, you get the offer or the order confirmation together with an information sheet that you are informed what to do and what we will do, and that you know what your technicians have to prepare on site. Another question which we have received is if you're just using 1, 2, or just a few positions of your OLTC. For example, you have 19 positions and you're using just middle, plus, and -1. So when you have a conventional tap changer in service, the maintenance in the interval depends on the application, so between 2 and 7 years. If you have a vacuum tap technology in service, then it depends on the number of switching operations. So if you're switching up and down just 1 or 2 positions, there's a long way to go to reach 300,000 tap change operations. So as I mentioned, this is in network application, this vacuum tap technology is maintenance free. What we can recommend is, if it's possible and the transformer is not connected to the grid, of course, that you every 1 or every 2 years that you perform some test operations over the entire range, that you clean the contacts a little bit. If these contacts are always on the same position, Of course, there can happen something, not that they are connected together. So if it's possible to switch to over the complete range, this would be very recommended. The chat is still open, so should there any question pop up regarding WAM, we are here to answer them. Also after the live webinar, then we answer the questions in the chat or via mail. This is no problem. We hope that you have enjoyed today's live webinar, that you gained some interesting insights, and we also hope that this information will assist you in planning your further maintenance program, that you considered some of our solutions for your midlife refurbishment, for example. As mentioned, the chat is still open. Feel free. We keep this video online, so with the link you can also watch the video again if you should miss anything. Should there any deeper questions coming up, we of course can arrange an individual custom meeting. We have our experts in the region. So from MR Germany, we say thank you very much for your attention. Enjoy the rest of your day. Goodbye.
Goodbye.